Now we have here a solved example here. Determine the critical points and locate any relative minimum, maximum, and saddle points of function f defined by f of x and y equals 2x squared plus 2xy plus 2y squared minus 6x. Now, as we did before, we need to find df and df dx, right?
Yes.
df dx is what? The relative to x is what? The derivative of this function.
4x plus 2y minus 6.
And we will equal this to 0 to find the maximum or minimum, the critical point. So df dy is
df dy with respect to y, it would be 2y.
no,
2x plus
2x.
y. 2x plus 4y, that's it.
And we'll equal to this to 0. To solve this two functions, we need to eliminate this is 4x and this is 2x. We can multiply this by this function by 2. So the 2 is multiplied here and here and here. So this will be 4x plus 8y equal to 0. And this function is 4x plus 2y minus 6 equal to 0. We can subtract these two functions. So 4x minus 4x is 0. 8y minus 2y is 6y. Minus 6 is positive 6 equal to 0.
Yes,
so this 6 can come here. So 6y equals negative 6.
And
y is 6, y equals negative 1. We can substitute in any function. Let's say this here. So 2x plus 4y equal to 0, which is 2x minus 4 equal to 0, because y is negative 1, right? So, yibqa 2x, this 4 can come to the other side, equal to 4 divided 2 divided 2, yibqa x equals to 2. Our point, the critical point is at, so the critical point is x, which is 2, and y is negative 1. Okay?
Yes.
This is a critical point. Now we need to find from here d2f dx squared is what? With respect to x again.
With respect to x, it would be just 4.
And from here, d2f dx dy with respect to y.
It would be just 2.
And from here, d2f dy squared is?
Is it 2? No, 4.
4. Now, what is d?
D, it's d squared f over d x squared.
No. D is this, multiply this, minus this squared.
Squared, yeah. So it would be 16 minus 4. It would be 12.
Greater than 0.
So it would be...
what about fxx or d2f dx squared is what?
So it's a 4, it's positive, then it would be an minimum.
Yes, minimum.
Yes, minimum.
The critical point is minimum. That's it. And this is a drawing of this graph. We will not draw, but this is
how it's
the point of the, yes.
Yes.
Now we can solve your problems first, right?
Yes.
We just solved this, and now we will solve this. You sent me these files.
Mhm.
This file and this file, we studied this file before. Definite integrals and areas.
Then there's another one.
This we studied this before, right?
Yes, probably. Yes.
I don't remember, but maybe we studied this before. Do you remember this?
Mm-hmm.
We studied this before.
But
And what?
I remember that there was second filing.
The second file is this, and it is empty. Nothing in this file.
Really?
It is empty. Yes. It is one file and it is empty.
SubhanAllah, why?
These are the two files. Okay. Now we have here.
Probably
Yes.
there is another one. I can yes, I can send it just a second. Yes, please just check it. I think it's full, it's not empty. Yes, it's already sent it. In Telegram.
Second order differential equations. Okay. This is okay. We will take it next time, inshallah.
Okay, tomorrow?
I don't know. Yeah, but yes, but tomorrow, inshallah. Now this one. Okay, we'll take it next time, inshallah. Next, tomorrow maybe, inshallah, we'll start in one of them. Do you have, for these files, you have PDF file for problems?
I checked what my teacher sent to us, and there was only these two files, like the theory only.
Okay. Maybe here in this file. Optimization function. Okay. Now we need to do what here? dh dx equals to what?
It equals to x.
And dh dy equals
2y.
negative 2y.
Yes, negative 2y.
So this will be equal to 0 and this will be equal to 0. So x here equals to what? Y equals to what here?
Y equals to negative 2.
لا, divided 2.
Yes,
so x equal to 0 and divided negative 2 divided negative 2.
Also equal to
Y
0.
equal to 0. The critical point?
The critical point is
at 0, 0.
Yes.
X, Y. So now
D, yes.
E to H dx squared equals?
It equals just 2.
Yes, and D to H dx dy is?
Equals nothing, 0. And
E to H dy squared is?
It equals negative 2.
Negative 2. So now what is D? D equals?
D equals 2 multiply negative 2 minus 0 squared. So it would be negative 4.
This is less than 0.
Yeah, so it would be saddle, yes?
Saddle, yes. The critical point is saddle.
Yes.
Saddle means not maximum, not minimum, like this. So this is saddle. The saddle of the horse. Like, right?
Yes. Right.
Okay. This is saddle. Find the critical points of the function, this one, and determine for each whether it is a local maximum, local minimum, or a saddle point.
So also you need to find them with respect to x and y.
Yes.
First, second derivatives. So it would be first. It would be 4x cubed plus 4xy. Yeah, that's it.
And we will equal this to 0. And df dy equals to what?
Yes. It equals 2x squared plus 4y plus 2.
This will be equal to 0. And we need to solve these two functions.
Yes.
Right, so.
But we need to find second derivative, yes?
Yes, but we need to find the point first. we can take a common factor here for x. For x common factor, and we have here x squared plus y equal to 0, right?
Yes, right.
And now here we can take common factor is no common factor, right?
Yes.
So from this, we can find that x equal to 0. Or x squared plus y equal to 0, right?
Yes.
طيب. And this means that x squared equals negative y, right?
Yes, right.
We will not have any solution from this. I'm sorry.
But can we
Yes.
continue from this point, or we need to come back from the beginning to beginning?
From here, now from here, if x equal to 0, we put x equal to 0 here, so 4y plus 2 equal to 0, right?
Yes.
This 2 can come here, so 4y equals to negative 2, divided 4, so y equals what?
It's y
Negative
equal
1 over 2.
Yes.
So our critical point is at first critical point at x equal to 0 and y equal to negative 1 over 2, right?
Yes.
And now if from here we can find that x squared equals negative y, right?
Yes, right.
We put here x squared as negative y. We substitute here in this function this. We substitute this in this function.
Yes.
So 2x squared equals negative y plus 4y plus 2 equal to 0. So this is negative 2y plus 4y plus 2 equal to 0, right?
Yes.
So this is 2y plus 2 equal to 0. This 2 can come here. 2y equals negative 2. Divided 2. Y equals negative 1, right?
Yes.
Now we substitute this in any function.
Which
say here.
Okay. So we just add the y instead of y.
Y equals negative 1 here.
Okay, so it's 4 multiplied
negative
1.
4 plus 2 equal to 0.
Yes,
so 2x squared minus 2 equal to 0. Minus 2 will come here. So this is 2x squared. What?
So what about 4? We had 4.
This one?
Yes, like, yeah, I understood. It's
y equals negative 1.
I understood. I mean, like, I didn't understand where did you get 4. So it simplified with 2. Yes, negative 4 plus 2. Yes, negative 2.
4 multiply negative 1 is minus 4. Minus 4 plus 2 is minus 2.
Yeah, yes, understood.
And now this minus 2 come to the other side. It will be 2 here.
Yes, so
divided 2. So x squared equals
1.
1. So x equals positive negative 1. So we have here 2 critical points. One, y equals negative 1. And 1, y equals, as the negative 1, y equals negative 1, 2.
But we also
so
need...
we have 3 points, 3 critical points. X positive with negative 1, and y equals negative 1, and 0, 1/2. 3 critical points. 3 3 critical points. This is 1, this is 2, and this is 3. Okay?
Yes.
I write these points here, down here. 0, -1 over 2, 1 and -1, -1 and -1. So we can have space. Right?
Yes.
Now from here, we need to d2f dx squared is what?
It is 12x squared plus 4y.
Yes.
So d squared f over dx dy, it's b plus 4y, just 4y.
4x. 4x. Derivative of y is 1.
Yes,
This is 0 because no y here. Derivative of y is 1. 1 multiplied 4x is 4x.
Yes.
d2f dy squared from here.
It would be 4, just 4. Yes, and here we need to find, in order to find d, we multiply 12x squared plus 4y to 4, and minus, yes?
Multiply what? No, we will calculate this. We will calculate this values. Add. The first critical point is 0 and -1 over 2. Second critical point, 1 and 0, -1. Third critical point is -1 and -1. So now x is 0, so this part is 0. And y is -1/2. 4 multiplied -1/2 is just -2, right?
Yes.
Now 1 and -1. X is 1, so this is 12.
12 plus minus -4, so it would be 12 minus 4, it's 8.
8.
Yes, and then, so it would be -12, negative.
Not -12. X squared is
yes, that also
1, 2.
-4, it also would be 8.
Now, this part here, x is 0, so this will be what?
It would be 0.
And this?
It would be 4.
And here, this one?
It would be -4.
And this one is 4, 4, 4. Because it is no x and y here. Okay?
Yes.
So here, d equals what here, and d equals what? Let's say d here. I write d here. Let's calculate d. What is d here?
It would be negative.
This multiply this.
Yes, it would be negative to multiply 4. It would be -8 plus 0. It would be just -8. Then it would be 24. No, 24. It's 32. 32 minus 16. Yes. It would be 16. And 32 minus positive 60 plus, no, minus 16 also would be 16.
So this point is what?
This point is negative, so it would be saddle.
So this point is saddle.
Yes.
I write it here. And this point is maximum or minimum, right?
Yes, it would be maximum or minimum.
Now I will put here fxx, which is d to f dx squared. So this it is here 8. It is here. We don't have to write anything here, right?
Yes.
It is already written. So this d here is positive and d here is positive. It could be maximum or minimum, right?
Yes.
So fx here is 8. So this point is what?
This point is, it would be a minimum.
Yes.
Yes.
Right. And this point?
It would be a maximum, yes.
Minimum too, because d2f dx squared is positive, so this is minimum too.
Okay.
So that's it. We solved it. Okay?
Yes.
I think it is easy, right or not?
I think yes.
Okay, but you have to solve by your hands.
Yes.
Inshallah. Right. Finish the problem started in this example. That is find the values of x and y that maximize the profit function. This is the profit function. So the profit dx is what?
So it would be 17 over 3 minus 5 over 3 multiplied 2, which means 10 over 3 x plus 1 over 3y.
Right. The profit dy equals?
It equals 28 over 3y.
Not y. 23 over 3, 28 over 3 only.
That's just it. Then negative 10 over 3y plus 1 over 3x.
We equal this with this to 0. So we can multiply this function and this function by 3, right?
Yes.
So we have here this 3 here and here and here and here. And this 3 here and here and here. So we have here 17 minus 10x plus y equals 3 equals 0. And this 28 minus 10y plus x equals to 0, right?
Yeah, yes.
And to eliminate, we can multiply this function by 10. So this will be, we'll have here 10x, and this is negative 10x, we can eliminate x, right?
Yes.
So we will multiply this here, and here, and here, and here. So this we have here 280 minus 100y plus 10x equal to 0, right? And we write this down it, right?
Yes,
this function. Now we write here 17, and this here minus 10x, and this plus y equal to 0. Now we will add, right? Addition.
Yes.
Because 10x minus 10x is 0. So this is 280 plus 17 is 297, right?
Yes, right.
And this is minus 100 plus 1 is minus 99y. And this is 0 equal to 0, right? We will take this to the other side. 297 equals 99y. Divided
So,
99, divided 99. So y equals what?
just a
3.
second. Yes.
Y equals 3. Now we will substitute y in any function. Let's say this function. Okay?
Yes.
So 17 minus 10x plus 3 equal to 0. So this is negative 10x plus 20 equal to 0. This 20 can come here. Negative 10x equals negative 20.
Yes.
Divided negative 10, divided negative 10. So x equals what? Huh?
Yes.
X equals 2. So our critical point is what? X is 2 and y equals 3. This is critical point. Okay?
Yes.
Yes?
Yes.
Am I solving very fast or what?
It's fast, yes, but the main to understand. Like.
But I want you to solve with me. Before I'm writing, before I write, you speak.
But of course, you're writing really fast that sometimes I can't just catch you.
I'll go a little bit slower, inshallah. Now we will have here some space. Now, so D profit, D2 profit, dx squared is what? With relative to x.
Okay. It would be negative 10 over 3.
Negative 10 over 3.
Yes.
And D2P dx dy is?
Is a positive 1 over 3.
And D2P dy squared is?
Y squared, it's a negative 10 over 3.
No.
So we need to multiply.
D is equal to what?
Negative 10 over 3 multiply negative 10 over 3 minus 1 over 3 squared. So it equals 109 over 9 minus 1 over 9. So it would be 99 over 9, and it's equals 11, yes.
So this is greater than 0. So this point could be minimum or maximum, right?
Yes.
Now, what about D2P dx squared is negative 10 over 3.
Yes, so
this is less than 0. So our critical point is what?
Maximum.
maximum. Find the values of x and y that maximize the profit. So x will be equal to what? 2, right? And y equals to 3. We just solved it before. The critical point. This is a critical point when the profit will be maximum. Maximize the profit. Okay?
But I just wanted to ask you, where did you find 2x equals 2 and y equals 3?
We just solved this before.
Okay.
We just solved this before.
I thought it's like a new one. It's not related to each other.
No. Okay. This one. 2 and 3. X will be 2 and y equals 3. This is a critical point.
Okay, good, understood.
Now, question 5.2. Monopoly manufactures 2 goods, X and Y, with demand functions X equals 12 minus PX and Y equals 18 minus PY. The firm's cost function is CXY is this, X squared plus Y squared plus 2XY. Find the maximum profit available and the quantities produced of each of X and Y in order to achieve this. Find the maximum profit available and the quantities produced of each of X and Y in order to achieve this. طيب بسم الله الرحمن الرحيم. Now DC dx is what?
It's 2x plus 2y.
And we will equal this to 0. dc dy is?
It's 2y plus 2x.
Right? Y plus 2x. So now we have 2y plus 2x and 2y plus 2x equal to 0. So from here and from here, we have 2x plus 2y equal to 0. We can take this to the other side. 2x equals negative 2y. Divided 2, divided 2. X equals negative y, right?
Yes.
X equals negative y.
So what's the next step? Like,
find the maximum profit available.
should we find second derivative or there is no need?
We need to find the second derivative, but we didn't get now. I don't know what is P of X. X equals 12 minus PX. X is the production of X, and this is production of Y. Maximum profit available. And the quantities produced of X and Y. I don't know, maybe we can X equals 12 minus Px and Y equals 18 minus Py. So X is equal negative Y, so this is equal negative 18 minus Py. Now we don't have solution to. Maximum profit available. Where is the profit? Huh? Maximum profit. This is the cost. And the cost. Where is find the maximum profit available?
For example, in a given X equal and Y equal P, is it cost or price?
This is cost. The firm's cost is this. The cost minus sales, or sales minus cost is profit, right?
Yes.
Okay, let's leave this now and see this. You have here F 553, and this is profit function, where X and Y are the quantities of X and Y demanded, respectively, and Px, Py are respectively the prices. Now this is a price. So the prices of X, so the profit equals the sales minus cost. So the P is price. So this is good information. The price of X, prices of X and Y. The firm's joint total cost function, that is the cost of producing X of X and Y of Y, is this. This is the cost function. Find an expression in terms of X and Y for the profit function.
We use any
profit equals,
I mean, like, should we use something like for economic lessons, like any functions here, or we can use what's already?
We'll see now. Find an expression. Hence, determine the quantities X and Y that maximize the profit and find the corresponding prices P, X, and PY. This is the last thing. For all values of the number k, the function has a critical or stationary point at 0, 0. For each value of k, determine whether this critical point is a local minimum, local maximum, or saddle point. We can try to do this. What do you think? D f dx is what?
So it says 2x plus ky, and df over dy is kx plus 2y.
And we will equal this to 0, and we will equal this to 0. Our critical point is 0 to 0. 0 and 0, right?
Yes.
0. Critical point 0, 0. طيب. For each value of k, determine whether this critical point is a local minimum type. Let's make the d2f dx squared equals what?
It equals 2. And
f
yes,
dx dy equals
just k. And d squared f over dx over dy squared is equals 2.
2.
And here we can find d, yes?
Yes.
So d equals 2 multiplied 2 minus k squared. So it would be 4 minus k squared.
So d equals 4 minus k squared, right? So if k is 1, d equals to what? Let's say d is k equals what I'm doing. K equals 0. So d is what? This is k, right?
Yes, it's just 4.
4. And k is -1.
Yes. It would be for -1, it would be 3.
K equals -2.
It is -2, it would be +4. It would be 2.
0. 4 minus 4 is 0. K equals -3.
It would be negative. It would be 9. 4 minus 9 would be -5.
And k equals 1.
It would be 3. Yes. It would
K equals 2.
It equals 0.
0. And k equals 3.
It is equals -5.
So k minimum, maximum saddle, the point k for each value of k determine whether this critical point is local minimum, local maximum, or saddle. So when k equals 0, so if which is d2f dx squared, it's 2 all the time, right?
Yes.
So this point is what?
Whether it's maximum or minimum?
Yes.
It is minimum.
Yes.
Next one is also minimum. I think all two here till the end minimum.
This is not, we cannot.
Yes, because 0, yes.
Tell.
Yes.
And this
is minimum.
But saddle.
Because it's positive.
Because d is -5. This we cannot tell because d is 0. This we cannot tell because d is -5. This is minimum. صح?
Yes.
And this is what?
It's we cannot tell. And the next one is saddle too.
This point is saddle. So if we draw something like this for k at 0 and 1 and -1, and so this is minimum, right? And for k equals 2 and -2, unknown, or we cannot tell. صح?
Yes.
And from 3 to infinity, and from -3 to infinity, the point is saddle. That's it.
So, for example, if I will have like the same question in exam, I can write like just this one, yes?
Yes.
Okay.
So we solved this. And now we need to solve 5-2, 5-2, and 5-3. And this one, this one. So next time, inshallah, because I have.
Remember. تمام أستاذ جزاك الله خيرا.
We have here only the one problem. This we solve with this. Second problem, third, fourth, fifth. 5 problems. Inshallah.
Tamam. But can we arrange a time for tomorrow? Which time is okay for you? As always, 11?
Yes, 11 is good.
تمام. تمام. جزاك الله خيرا. شكرا. Have a nice evening. السلام عليكم.
السلام ورحمة الله.